The last topic that we want to cover in fluid statics is buoyancy. So imagine there is an object, let's say this is the object that I place in the fluid, and I am interested in figuring out what is the buoyant force because of this object. So we have already studied what is the force acting on a submerged object, and now this is a solid object which displaces a certain amount of fluid, and there is a net force on this object because of that. So a 3D object submerged in fluid, and this, let's say, is the atmospheric pressure, and the volume of this object is V. I am going to break this into two parts. So there is an upper surface of this body. So this is the upper surface, and I am going to talk about a lower surface. There is a pressure force that acts on the upper surface, and there is a pressure force that acts on the lower surface. And if I can find the resultant of the force because of these two, then that would be the net force acting on this body, and I would call that as the buoyancy force. So please recall that the pressure is always normal to these surfaces. So first I would like to calculate what is the force on the upper surface. And that's easy to calculate because I would have to take this prism, so this entire fluid rests on the upper surface, and the resultant would be simply, I can calculate because of the volume of the pressure exerted because of the volume of this, and that would be given as rho g, let me call this as Vu. So Vu is the volume of the prism on upper surface of the body. Now I could talk about the pressure force on lower surface, and that would be given as rho g V bottom, and that would be this prism. So this region is the bottom surface. So if I now want to calculate the net force, then you can see that the net force on the lower surface, please note, is going to point out the pressure here is like this. whereas on the upper surface the pressure is somewhat like this. So the net force that I am going to generate is a force rho g, which is V bottom minus V upper, which you will notice is actually rho g times V, which is the volume of the body. So if I look at the difference between the bottom prism and the upper prism, then that is simply the volume of the body. So this is the Archimedes principle. That the buoyancy force experienced by a body is simply the weight of the fluid it displaces. So if I talk about a balloon, so suppose I talk about a balloon, then there is a certain buoyancy force and there is a certain weight. For it to remain static, these two to be in equilibrium, these two should be equal. The weight should be exactly equal to the buoyant force. But then if I fill up it with a gas such that the buoyant force is larger than the weight, then the balloon can rise. So we all know this, but it is good to see that actually coming from the equations of fluid statics. So we will stop here. I will assign you some homework problems which you can practice and learn the concept on fluid statics. Thank you.